Chapter 3, Vectors and Motion in Two Dimensions. Section 3.7, Projectile Motion, Solving Problems. We can solve projectile motion problems by considering the horizontal and vertical motions as separate but related problems. There are a number of steps you should go through in setting up the solution to a projectile motion problem. You make simplifying assumptions. Whether a projectile is a car or a basketball, the motion will be the same. Draw a visual overview, including a pictorial representation, showing the beginning and ending points of the motion. Establish a coordinate system with the x-axis horizontal and the y-axis vertical. In this case, you know that the horizontal acceleration will be 0 and the vertical acceleration will be free fall. So a sub x is equal to 0 and a sub y is equal to minus g. Define symbols and write down a list of known values. Identify what the problem is trying to find. There are two sets of kinematic equations for projectile motion, one for the horizontal component and one for the vertical. Delta t is the same for horizontal and vertical components of the motion. Find delta t by solving for the vertical or the horizontal component of the motion. Then use that value to complete the solution for the other component. And finally, check that your results have the correct units. It is reasonable and it answers the question. We need to prepare. We start with a visual overview of the situation as shown in the figure. We have chosen to put the origin of the coordinate system at the base of the dock. The dog runs horizontally off the end of the dock, so the initial components of the velocity are v sub x I is 8.5 meters per second and v sub y I equal 0 meters per second. We can treat this as projectile motion problem, so we can use the details and equation presented in synthesis 3.1. We know that the horizontal and vertical motions are independent. The fact that the dog is falling toward the water doesn't affect its horizontal motion. When the dog leaves the end of the dock, it will continue to move horizontally at 8.5 meters per second. The vertical motion is free fall. The jump ends when the dog hits the water, that is, when it has dropped by 0.61 meters. We are ultimately interested in how far the dog goes, but to make this determination, we need to find the time interval delta t that the dog is in the air. We'll start by solving for the time interval delta t, the time the dog is in the air. This time is determined by the vertical motion, which is free fall with an initial velocity v sub y I is 0 meters per second. We use the vertical position equation from synthesis 3.1 to find the time interval. Rearranging terms to solve for delta t, we find that the delta t is 0.35 seconds. This is how long it takes the dog's vertical motion to reach the water. During this time interval, the dog's horizontal motion is uniform motion at the initial velocity. We can use the horizontal position equation with the initial speed and delta t is 0.35 seconds to find how far the dog travels. That is the distance we are looking for. The dog hits the water 3 meters from the edge of the dock. 3 meters is about 10 feet. This seems like a reasonable distance for a dog running at a very fast clip off the end of a 2-foot-high dock. Indeed, such is a typical distance for dogs in such competitions. The range of a projectile is the horizontal distance traveled. For smaller objects, air resistance is critical, and the maximum range comes at an angle less than 45 degrees. Projectiles 1 and 2 are launched over level ground with the same speed, but at different angles. Which hits first? Ignore air resistance. A, projectile 1 hits first. B, projectile 2 hits first. C, they hit at the same time. D, there is not enough information to tell. The answer is B. Since it goes higher, projectile 1 will spend more time in the air. Therefore, projectile 2 will hit the ground first. A grasshopper can jump a distance of 30 inches, which is 0.76 meters, from a standing start. If the grasshopper takes off at the optimal angle for maximum distance of the jump, what is the initial speed of the jump? Most animals jump at a lower angle than 45 degrees. Suppose the grasshopper takes off at 30 degrees from the horizontal. What jump speed is necessary to reach the noted distance? Using the max range equation, we find the initial velocity must be 2.7 meters per second. Using the range equation, we find the initial velocity must be 2.9 meters per second.